I want to talk about how we can solve for x, solving kind of quadratic equations when we have vertex form. And vertex form is using the translations that we've been talking about and that I've had videos about thus far. So let me just explain. We know it's a parabola because we have this squared power, so that's what gives us this shape. We know that it has been moved to the right 2 units and down 4. So there's its vertex, over 2 and down 4. And then that 3 out front is what makes it stretch. So it's growing with a vertical stretch, so 3 times faster than it was before. Now, if I were to say, when is this equation equal to 8? What that means is that we need the y value. We want to know what x value makes y 8. So we could come up here and say, well, here's 8. I could, I suppose, draw the line the whole way across like that. The 2 x values that make that true are 0 and 4. So there are 2 answers that make this true. There are 2 different x values that I could plug in. I could plug in 0, and I want you to think about this for a second. 0 minus 2 is negative 2. Square that, and we get positive 4. The other x value was 4. Well, 4 minus 2 is 2. 2 squared is 4. So both of those x values give the same value once we've squared it. And this really has to do with because squaring made it positive. So plugging in 0 and squaring it, plugging in 4, squaring it, gave us the same output. The shape of this function dictates that most times we'll have 2 answers. Okay. Now I want to show you how I would solve this without needing the graph. I would almost treat this piece right here, this part in the parentheses, almost like its own variable. I would almost treat it like it's, like 3 times, I won't use x. Let's say it's like 3f squared minus 4 equals 8. And I would just solve all the way around it without solving that. So, for example, what do you always do first? Well, you start by adding 4. So we've got 3 times, I'm going to leave that x minus 2. Again, that's going to be the last thing I work with. Then I would divide by 3. So I've got x minus 2 squared equals 4. Now at this point, I'm going to take the square root. Square root. That's how I'm going to get rid of that squared power. Now, the square root of something squared is just that thing inside. It's just x minus 2. But over here, this is the key. When you're solving with a square root, we have 2 possible answers. Positive 2 or negative 2. And again, this goes back to the fact, remember I said when we plug these numbers in, 0 and 4, 0 minus 2 is negative 2, but squared is positive 4. 4 minus 2 is positive 2 squared. We have to recognize that both positive and negative 2, when inside these parentheses, will work. Now, I would just add the 2 like this, and then I would write 2 things down. The first thing I would do is I would say, well, a positive 2 plus 2 is 4. And then I would do a negative 2 plus 2. Negative 2 plus 2 is 0. And there are my 2 answers. Okay, let's do another example. So again, I have my my vertex form. You can see I was moved to the left 1 and up 3. So left 1, up 3. There's my vertex. That negative is what made it go open kind of down instead of up. And of course, it's stretched. Let's say I wanted this to be equal to 1. I wanted to figure out what, and again, if you think about the graph, you can see the 2 spots where we are going to be able to get a y value of 1. Let me start solving. I'm going to begin by subtracting 3. So negative 2, x plus 1, divide both sides by -2. So x plus 1 squared equals 1. And again, this is the part where we get our two answers. We're going to take the square root of 1. We're going to put plus or minus 1 over there. Always remember that plus or minus. That's how we get our two answers. Then I'm going to subtract 1 from both sides like this. And again, I would just start by saying, okay, positive 1 minus 1 is 0. Negative 1 minus 1 is -2. And there are my answers right there, -2 and 0. Okay? Do not forget to put that plus or minus. That's how we're going to get our two answers. Now, one thing I just want to point out here before we end. If I said, when is this going to be equal to 7? Okay? Now, 7, obviously, it's up here. It's even off my screen. This graph, that's not even in its range. It's never going to be up at 7. Well, let me show you how solving would catch that. Let's say you subtracted your 3, just like always. So you got -2 times x plus 1 squared equals 4. You divide both sides by -2. So x plus 1 squared equals -2. And right here, you take the square root, and that's where this thing falls apart. We cannot get a real solution taking the square root of a negative answer. So that's how you would catch it without a graph. If I asked you to find the x values that went to a y value that the parabola won't ever touch, like I did in this one. Okay? Now, do not be afraid if the answers come out to be, with square roots. For example, if I said, when is this thing going to be equal to 2? And you said, well, subtract 3. -2 times x plus 1 squared equals -1. Divide by -2. So x plus 1 squared equals 1/2 or 0.5. And then you take the square root. Well, that's not a nice answer. So you have x plus 1 squared, or x plus 1 equals, and we write plus or minus the square root of 1/2, like that. And then you subtract 1 just like always, and you just kind of leave your answer like this. If the square root doesn't come out nice, if it's not a nice whole value, we just leave it. We just leave it under the root. That's simplified. Then we don't have to use decimals. We don't have to round. We can write it just like this. If this video helped you, please like and subscribe for more math help.